last type of example I'm going to show you is one where we write a sum as a product of trig functions. Now what's interesting to note on this is that the angles are not actually numerical values, they're expressions, right? They're algebraic expressions, 4x and 8x. And so I don't actually know those values, but we can still rewrite them as a product using our sum to product identities. The one in particular that we're going to use is the one that has the cosine of an angle A plus the cosine of an angle B. On our table, it's the third one down, and it is the one that has cosine A plus cosine B is equal to 2 times the cosine of A plus B over 2 times the cosine of A minus B over 2. All right, so that's the product. And so then we're just going to plug everything in as needed. The A and the B get plugged in here, so we get 2 times the cosine of 4x plus 8x over 2 times the cosine of 4x minus 8x all over 2. And if I simplify each of those angles or arguments in the trig functions, 4x plus 8x is 12x, and 4x minus 8x is negative 4x. And then we reduce the fractions, right? 12 over 2 is 6, so it's 2 cosine 6x times the cosine, negative 4 over 2 is negative 2x. And now one thing I noticed is I have this negative inside of an angle. Whenever we have that, it's nice to use the odd and even identities to eliminate that negative. What we know about the cosine is it's an even function, right? And I'll go through this whenever I use these just to establish a way that you can, if you don't have these memorized, a way that you can kind of rationalize through them. Your cosine is an even function because it has y-axis symmetry, okay? And so that means with an even function, f of negative x is equal to f of x, right? The outputs are the same when you change sign. If you have a positive x or a negative x, the outputs are the same. They go to the same place vertically. And so what that means then is that the cosine of a negative angle is equal to the cosine of the positive angle. The negative literally disappears. It can be removed. And it doesn't come out like it would with a sine, it's just gone with a cosine. And so what we could write this as is 2 times the cosine of 6x times the cosine of 2x. Those are actually equivalent, okay? Yeah, and so now we've established a sum as now a product. Obviously, they're two different angles, right? Instead of 4x and 8x, we have 6x and 2x. But we've rewritten it in a similar way, or in a, using a product instead of a sum.